Hello everyone, welcome to HoudiniFX, and today I'm recording my first English tutorial. Actually, I've been recording in Turkish for over a while now, and I want to start things off with same as my channel in Turkish, that is being the mimic. And this mimic was inspired by BBBN19's, actually it's his former name. Right now he's called Cartesian Caramel, and we will create this effect that was inspired by his breakdown that posted almost 2 years ago. I will put the link below. So if you haven't heard of him, just check him out. He posts very regularly and great stuff. Today we'll be doing this. So how are we going to do this? According to breakdown and what I have studied, we will first of all create these feet. You see, these feet are actually in this manner a normal curves that spread along, that's scattered through this grid. So we have another foot here, we have another one here. So what will we do? We'll first create these roots, scatter them along this grid on the points everywhere. Then we will create our point that's creating its animation through the grid. So let's delete this before first. Now what will we do? We'll create a swept curve. You see, we will create a curve and we'll have a point that's following it through its course, and we'll put a point on top of it, and that will be our main point. So it will be working on it like this. And then what will be happen with this curve and our roots? We will connect them to each other. First of all, we will connect all of them, so everyone will reach here. We'll create these, and after that, we create the distance mask along with through this point, we will retract what's far away. You see, just in the before frame, where are we? Let's check it out. You see this retraction, it whoop takes it back. We will reach out, then we will take our arms back. We will work on this. Now in my first record, the creating the base geo took a lot of time while explaining everything, so I created a basic one to go over it together. Now let's go to our shot. Now, as I said, I just drew a curve on the front. You see something like this. Then I resampled and edited that a little bit, just give it a little twists and fallbacks, etc. Then I resampled again to get this beautiful line with creating curve U attribute. That's important because we are using curve U a lot. After that point, I wanted to create I copied them. I will go through this together again. You see this? We'll have a 6-legged root that's connecting all over the place. Now, I wanted to create a spiral where they meet together in the middle. For that one, I wrote a wrangle, but I want to write it again so that we can work together on this part. You can use a twist modifier, twist node for this, but I like wax, I like wrangles, I will write them a lot in this channel. So let's delete this, we'll write it from the beginning. So what will we do? First, I want everyone to turn to create the basic setup. Everything should start from proof of concept to finalize. So first of all, I want an angle, float angle. Let's create a float channel for that. How much I want to turn, that's what I'm using for. After that, I will create a quaternion, vector 4, actually vector 4 named rotation quaternion. And for this one, I will use a quaternion function. What is quaternion function doing? Let's open its help file and see inside. So creates a vector for representing a quaternion. I want to create a quaternion that says, okay, rotate by this angle on the y-axis. So I want to create a twist like this. I have to rotate along y-axis. So it takes an angle and an axis. This is the function that we'll use. So the angle I already wrote it, angle, and axis, I want the y-axis, 0, 1, 0. After creating this quaternion, I will just rotate myself along it and make that one my new position. What I mean by that, pos equals qRotate. That's the function that we're gonna use. qRotate. Let's open the help file again so that you can see better. If I just Ctrl plus here, let's make it a little bit bigger. Okay. Returns a vector v rotated by the given quaternion. That means I will give it my position and make it rotate on this quaternion, on y-axis, on this angle. Let's see, rotquad. We will give the quaternion first, then the vector. Okay, now let's see. Why is nothing happening? Because we just created a pos vector, but we haven't set our p. Now we'll see something. You see, we are all turning. That's good. But I'm just going to one, and it turns a lot to turn on 1 degree. I want to work in degrees. That's because the quaternion function in here actually it wrote. We just misstepped. You see, the angle is specified in radians. Just make it bigger so you can see. Maybe a little bit too much, but okay. The angle is specified in radians. So this is radians, but I want to write in degrees. What can I do? I'll just put this in a radians function. This way, what I write here is transformed to radians, then used in the quaternion function. Now, 1 degree is too little. I want to make this slider bigger, so 720. Okay. Now, you can see we are turning in 270 degrees, 360 degrees, etc. Now, we've created our basic setup, but I don't want everything to turn. This is not a spiral. I want to turn from here, for example. How can I control that? Using the curve U attribute, and that is this attribute. Let me show you this curve U. So red is 1, blue is 0. It goes from 0 to 1 towards the end of the curve. Now, how can I use that? First, if I use it directly, let's see what will happen. I will just angle curve U. Okay. I will just multiply it with the curve U. So what happens? I will just close this. You see, top side stays. The spiral happens, but it only happens to the bottom side. This is also a good view. You can use this one as well. It's actually a better one, maybe. We'll see. But if you want to control it, first create a ramp. Let's do it like this. So I want to create a new float named bias, and I will create a ramp channel that's called twist bias, and evaluate it using curve U. Okay. Now I create my parameters. You see, we have a 0 to 1. Now everything works differently. Nothing changes. Why? Because I'm an idiot. Because in here I used only angle. I need to angle times bias. Okay. I need to multiply it through it. So you see, 0 is 0, 1 is 1. If I reverse it, bottom stays same. Let's circle it down. You see, this is how it happens. But I want bottom to rotate as well a little bit. Maybe on the other direction as well. You see, this is how we are going to control this rotation. Now, if I make everything 1, you see everything rotates together. Nothing changes. I need to decrease this. So if I use it like this or collect it, my feet will be in the same place, but I like this spiral, so I will keep it like this. Maybe it will give us a rather different or more sophisticated view, but this is a little bit too much. Let's see. I want this to be 0.5, this to be 1. Let's see what we will see. Okay, top side turns a lot, bottom turns a little bit more less. Okay, that's fine. Then I have transformed it a little bit upwards. That's for when it connects. It's needed. It was needed on my R&D, so you might not need it as well, but this looks better. Let's just close it at the beginning. Maybe we can open it later. Then what I have done, I wanted to create the grid points to where do I want to scatter this. So I create a grid, simple grid, bend it, and I create a camera to see what am I doing. Then I put normal attributes and create normal and up attributes. This is actually a little bit important. Let me show you. I want normal attributes here. You see, I changed my normals. Why did I do that? I changed my normal to x-axis and up axis as my old normal. It was my normals like this, but I did it like this. Why? Because when using copy to points SOP, when we are copying our roots here, it uses normal vector as front. So my roots front will be here. Let's see. This axis will become here, and up axis is y. So that's why I changed the side of the normals and scattered my points. They inherited the normals and up vectors. Then I created an instance attributes node. That's only for creating randomized p-scale and randomized spinning around the up axis. And when we use copy to points, we can see better. Let's go. So you see we have all kinds of swirly and differently sized, but they're all turning the same side. Maybe we can change that later. Now if I come here and change the seat, you see they're all changing. Let's get closer. Because they're randomly rotating and randomly getting their scale from 0.8 to 1.2. So this is our root setup. We have scattered our roots throughout the whole grid. Then what I have done, for the point I want an animation, not just a point that's floating through the space. So I drew a curve on this grid, then resampled and used the polyframe. Now in polyframe node, you cannot calculate the curve's normals if you use a normal SOP. Only the polyframe node helps there. It calculates our normals, tangents, etc. And in here I have seen that tangent v attribute can be used as my up function. What can I do with it? I can create an offset of it. What I've done here, I'll just quickly go over it. So you see I have a reference curve u attribute. This is it. I'm taking the position of this point's curve u, this curve u here, the position of it, and creating an animation on it. And then I just, a primitive sphere, I copied onto it, I took its position, and that's it. That's my origin. That's where all the points will try to connect. I mean, let's show it on here. That corresponds to here. So that's where we reach and retract. Okay. Now let's keep going. Now what will we do? You know, I want these points, all of these points, to connect to that. But before doing that, I need a reference to keep or delete them. What I mean by it, I need a mask. How close these are to this point. Let me show you like this. Okay. You see my point C is here. That's floating around in the animation. I want to create a mask along this one, so delete others that for not seeing them, and I don't want that kind of a mess. Let's create a mask from geometry. Mask, not along, mask from. So there are many different masks two actually. Mask from nodes, we are using mask from geometry. It takes two inputs. One is our geometry, second one is our reference geometry. This creates a mask attribute. Let's show it off as well. Maybe this will make it look better. Okay, now, yes. In a 1 meter radius, we are creating a mask attribute that's 1 to 0. If I make it 10, so 10 being 1 here, and it getting decreased through fall off to that. You see, this is our mask. I think the 6 meters should do the trick. But you see there are little bit mistakes. You know why is that? Because we are using reference group type of primitives. I want a point. I want to evaluate this as a point, not a primitive. Okay, now I want to blast some of them, or many of them actually. Blast. We have a point attribute named mask because copy to points node copies the attributes to scatter points as well. At mask, if at mask is smaller than 0.01, they are all just deleted. Okay, now I want to work with these points. That's good. And I have my origin here as well. Let's just do the opposite template here. Yes. Now I want to connect these points to here. How can I use that? I will use a linear interpolation with curve U attribute. What will this do? You see this up top points will connect, but as it goes down, it will try to connect, not connect. I can visualize it, I think something like this, huh? I'll just create a new page. Okay. Now let's assume this red one is our original line. And we want to go to this blue dot. Now in linear interpolation, if all points will try to go to that point. How is that? Let's first of all create the points. I will assume there will be 5 points. Okay. Now linear interpolation says just go from here to here. Just like this. Okay. All points try to go to here. Okay. Now with the given curve U attribute that we have, I will write them right behind them as well. So 0, 0.25, 0.5, 0.75 and 1. Now linear interpolation takes and t, the bias argument as well, not an argument, variable as well, and that works like this. You know, if I use my curve U as a bias for my linear interpolation, this says how much I will try to go to new position. Now if I open it with the yellow, okay, now what does that mean? So if my curve U is 1, I will try to go to this position with a strength of 1. I will come here. So this is my new position. This one goes all the way. Second one, I will try 75% of my power, so I will come around here. This is new position. This will go to half of it. This will go to 25% of it. This will not go at all. So my new curve will become something like this. So we will use this function's power in here. So let's go. How can I do that? Let's take a wrangle and call it reach. Now in this wrangle, I want to connect my origin points to my second input. Okay. Now what will I do? Let's just take the position of the origin first. Vector origin equals point first input. Yeah, it starts from 0, so it's the second input. position of the first point. As there is only one point, this works as this is the position of this point. Now, let's first of all, let's create a bias to show you how lerp function works. Reach bias. And let's create v at p equals lerp linear interpolation. I want to start from my position, go to origin's position with bias power. Okay, let's create it. Now what will happen when I take this to 1? Look, all points are going for that new point. Everyone became here, same as our origin. Now I didn't want that, I don't want that. I want them to use, like here, their curveu attribute as a power for how much I'm going there. Yes, we can create that one as well. This is Houdini, let's go for it. You see this bias, I create a float. Now I don't want this float to be used, I want a different type of approach using curveu with using ramp. So I will just delete this and delete all spare parameters to get rid of that. Now I will create a ramp channel called reach ramp, and I will use curveu to evaluate it. Now everything should be working. You see, it's all turned all around, it's reversed because I started drawing from top, that's 0, bottom is 1. If I reverse it, you see our power. Now I'll just take this a little bit less to create that. Now that's that I want to put the transform node here to, you see this is our current one. This takes a little bit too short, I want to make it longer like this. Now if we see the reach, you see they are trying to collect like with this bump. If I take a little bit more, okay, I think that's a little bit more like it. If we want, we can make it a little bit larger as well. If I take it 3, you see, if you don't want this to crawl around the floor, if you want to get it a little bit higher, we need to use up offset a little bit more. So let's say 0.5, yes. You see we have something like this. Let's watch it before going anywhere else. What have we done? So the animation starts. There is no retracting. We are just reaching all the points that exist in the 5.5 meter radius to middle. So that's actually working. It's good. Now I want to retract everyone. That's far away. But I don't want to just create another retraction through here. You see, I can use a mask attribute. This is a rather simpler function, not just function. This is a rather simpler approach. You can create per primitive masks to create a better alignment. You see, one of them retracts, the other one doesn't that much, but I want to use them as a whole. So I will use this simple mask here as my main part. I will use this mask, but you see there's a ramp here. I will use this mask something like this. I want more zeros around it. You see, this will all be footing down. As it gets to 0, it will be retracted to the original position as well. Now this is reach. They are all reaching out. I will use this mask attribute to decide how much I'm retracting to the origin. Now how can we do that? If I use it with linear interpolation just like this, it doesn't work. Why it doesn't work? Because right now my origin is here. You see, my positions are here. Let's draw it. You see, this is my foot, right? If I use linear interpolation, this position will try to retract through this path. I don't want it. I want it to go through itself. Now how can I use that? We can use the premuv function to get the position of this place. You see, I have a bias, how much I am retracting. So if it's 0.75, I know this curve, just go to the 75% of it, or half of it, etc, etc. Now, that's why we are not using lerp function right now. We will use a different function that's called premuv to decide where we are going. Now, let's go to the rank. We will call it retract. First of all, I want to create my bias. Or let's use a float before as a proof of concept. Okay, float bias equals bias. Now, I want them to retract, right? Let's use it with the curveview attribute as well. But as we have used before, the curveview attribute is reversed, so I will just need another ramp to use it. Float and curveview, new curveview. Actually, it's used in normalized, but let's use it like this time. Okay, we'll create a ramp. That's called curveview ramp. We'll evaluate it using f@curveview. curveview. Now, let's create our bias. You know, v at p eşittir equals to, first of all, let's create a pose and call it where we want to go towards this thing right now. This curve, we will work it as a singular once. And if we want to show it to you, I can do something like this. First of all, let's create a for each prim to see what we are doing one by one. This is just for visualization purposes. We ain't gonna use it a lot. So we are using for only this curve right now. We are only seeing this curve. Now, pose equals to premuv function. Let's see what does premuv want. It wants a geometry attribute name, prim number, and UVW. Okay, let's go. Geometry 0, attribute name position that I'm looking for at prim num, and UVW is and curveview times bias. What am I doing right now? I'm retracting them with this bias. So if I used only curveview, they will be sitting right the same place before. Let's see. You see, nothing changes here because there is a curveview attribute. Let's go for 0. It says go to these positions. Let's go for 1 actually. Let's look from 1. Go to these positions, 1 curveview. It's exactly the same place. Nothing changes. But if I multiply it with the bias, now we will have something different. But we haven't used our P as. Now we'll see. You see, this was before. First curveview was still at the first curveview. Then I retracted through the origin. Let's go for this one. You see this? Let's go for all of them. Let's see on all of them. You see this? When I go 0, they are all retracted. When I go for 1, they have all opened. Now, I want to use mask as another attribute here. So let's go for it. This curveview ramp will decide with the mask how much we want to retract it, how fast we want to retract it. So in this bias, I will just use f@mask. In the bias, instead of this number, I just want to use my mask attribute. You see now, we are starting to retract them through our mask. If I collect it here. Let's see what happens. How fast we are declining. Not that much actually. So maybe we need to rewrite this part as well. Let's check it out first of all. Oh, okay, yes. Maybe we shouldn't use the ramp for curve view attribute. We just use it as it is. We use it for the bias mask. So let's rewrite this part. This doesn't do what I want right now. Okay. Now I will just delete all parameters to start from 0. Actually not 0. I like this part. This part can stay. F at curve view time bias. Now I need a bias. Let's call it bias. I need a ramp attribute. That's called mask ramp this time. And I want to use the mask attribute for it. Let's see how it goes. Okay, right now my masks 0 is 0, 1 is 1. I want to take this a little bit later. And you can use the sharp and collect it like this. This way, many of them won't even touch the floor or try to touch it. You see? They will just reach out and come back. Now this is actually what I want. Maybe there are a little bit too much points right now. That's too many feet. So I will go to scatter and scatter less points. So let's go for 1000. Now what we see, more relaxed. Maybe this one's better. Relaxed and less points, that's coming from there. This is actually going well. Now, I want, this can work as it is as well. We don't need to do this like this. You see this prim, for each prim, this was only for the visualization. I don't want to use it. I will be using this part. Okay. Now, I am retracting and reaching out, all as the same. If I sweep it using sweep node and connecting it here with the round tube. Now I want more columns. Radius is smaller and apply scale along curve. This will help me to retract the top and bottom parts. I will just use something like this to create this kind of an effect. Maybe this is a little bit too much. Something like this. And the general radius should be way lower. Okay. Now let's see what is happening. Now I can see the basic of this system works. Now we can go to the artistic choices actually, because our FX's basics work. As I said, how can we do that? We can use a simple attribute noise right now, but that attribute noise might not work. Let's see, first of all, I will show the debugging of it later. Now I want to use the P attribute. You see everything goes wild right now. It only looks for the position and creates a noise on it. Now I don't want the Y to be collected to see it here. Yes, only X and Z. Actually, if we gather the up vector, you see from the first scattering node, let's check it out. I want to see if I have the up vector. If not, I want to copy it as well. In the copy to points node, there is copying attributes. It's secluded here. You see, it's excluded, but I don't want it excluded. I want to get the up vector as well, so I'm deleting it there. But I still don't get the up vector. Let's see. So in here, I have an up vector, right? I don't have an up vector here. Oh, because labs instance, okay, instance attribute creates it to orient attribute. So I don't want to clean up. Let's add up vector here as well. Okay. Now, if I get to the point, now I have the up vector. Okay. Now we can see them. You see this up vector? I want noise to work on not this part alone. Now let's see if I can do that. If I use noise along vector and use up, it will only push on the up, right? Or use it as the main base. Let's see if I, well, actually it didn't work. It only put on the up, and this is not what I want. I just want to exclude the up vector actually. Maybe we can focus on what we are doing right now, then we can do it. Yeah, that's just up. Let's close the up vector and y. Okay. Now amplitude gets way lower. Element size gets a little bit lower. Now let's see what is happening. You see this, but this is, you see these kinds of groupings because they are positioned very close at first. These positions are too close to each other. That's why this grouping happens. They move together in the noise because they don't get enough different data. Their position is too close. How can we do that? We can, let's see, you know, in here, before deleting anything, because deletion is changed the point order or primitive order, I can create an enumerate node to create a prim ID. In primitives, I will create a prim ID. Let's check it out. You see we have a prim ID attribute here, and after the blast, prim num is 160, 167, but prim ID is different. This stacked together. This stayed as before. Although prim number and primitive order changes, this stays same from the beginning. That's why I'm creating this index attribute, prim ID attribute, to use it as offsets in here. Now, we know that offsetting this data changes our noise. And using the expression, opening the expression here, if I create an offset equals random prim ID, what does it do? Let's see. Now it didn't work. Why? Because this attribute noise works on point level. If I use it on prim ID, it doesn't work. What should I do? I can promote it to point level. Attribute promote. You see this point primitive to point, and it's the prim ID. You see it changes. Every primitive has a different offsetted noise. Maybe we can actually not use rand but just prim ID. Now you see everything is a different offsetted noise type. Let's come on here. Well, although this seems like working, I don't want these to get that much of a noise. How can I use that? I will go here and open the blend by attributes and use the curve view. Now using curve view, you see we have a rather exactly the inverted type of curve view. What can I do in that regard? I can create an attribute remap node. I will use curve view attribute. I will change its name to noise mask, and I will use this map right now after getting it here. Let's put it noise mask. Okay. Now in the attributes remap, what changes I do here, you see it all changes together. If I put it like this, now we have a noise that's going down through the zero. Maybe we can get this something like this as well. You see? We have something like this right now. And that's way better. Now what we can do, this is actually the end of our part. We can use the sweep node. Before using sweep node, you know, there will be a lot of confusions here. You see these pushings, it's almost pushing on the same level together. And what can we do about that part as well? Let's see. X, Y, Z. If we add Y, you see this is a problem. There is a point, there is a primitive that we have retracted to 0, and it has, let's say, 50 points. All 50 points in the same place with different curve views. So this acts very badly. So after the retraction, after I retract, I want to clean them up. How can I do that? I will measure their length. This is from here, length per piece, per element, per primitive element, yes. Then I want to blast them according to that. In the primitive, let's see what was the attribute's name. Perimeter, it's perimeter smaller than 0.01. Let's go. So how much does it? Now we have 4.5 thousand. We had 8.8 thousand. Almost half of them is deleted. So there are a lot of noises in this part that has been redacted. Okay. Now let's go. If I open up to close the Y, okay, let's go. Now, why am I opening the Y again? Because I already blended them to 0, so it doesn't change where my foot stands. Maybe even a little bit more I can put it. It's on the remap. Let's just take it a little bit more. Okay. Now in the attribute noise, its range values to positive. If I take it to 0 centered, okay, now it's a bigger mess. We can adjust noise, add element size a little bit more, and 0. Let's say 3. A little bit noise, less noise. Now if I look at from the sweep, let's see what we will see. The foods are way too similar. Maybe we can work on different noises, working only on them. But for right now, we can stay here as well. Maybe with a little bit closer camera to improve the dramatic effect. But in half of the time we don't even see it. So let's go something like this. What we see, okay, it goes through us. Okay, I'll turn a little bit more. Okay, now we have a mimic that's coming towards us with different tentacles that has different noises, and you know, let's just in the sweep, let's just put it a little bit more so that it's just as in this part has a little bit more thickness, and cap single polygon. For these kind of drastic changes in the angle, we can use a subdivide node, smooth node. They can all work well together here, or just a resample node even. Let's try that resample node. If it works better, we can use that one. Let's see. I want to use this as subdivision curves. No, maybe. Well, subdivide will work better, I think, right now. Okay. We have a little bit more smoothing. Maybe a smooth node as well, to make them a little bit more smoother. Now, let's see what happens. Nothing much, they just gets a little bit more relaxed. But if it works, it works. Okay, now if we sweep it, you see this. Now as we have created a prim ID attribute before, I can use to color them as well. Before sweep, it will take it there. Now, let's go for primitive. Well, you see these primitives have different colors, but as the prim order changes, the color changes as well. I want to use the prim ID attribute. What can I do about it? I will put a prim wrangle. Oh, actually my on the point, right? My attribute is on the, let's see, not prim ID is on the point. We have promoted it. Okay. Now let's set CD. Now in here I will create a color set, you see. But before doing that, I want to float random bias, random dedim, rand attribute, rand function to use at prim ID. I will create a random number between 0 and 1 looking for the prim ID. Then I will create my color according to it. CD shrimp color sets, and I want to take it through ramp. Okay. Now I need to change this ramp from float ramp to color ramp. You see, it's rather easy. Now I apply it. Now what kind of a color ramp I get here? Every primitive gets a random position, random color from that. Let's go for Inferno. Why didn't it work? Let's check it out. So let's go for black body. They all have the same. I'm just looking at prim ID. Oh, I'm not working on the point. Now it works. Okay. You see, everyone has a different color, and here it stays as well because we use the constant attribute, not just prim ID or pt num, not just prim num or pt num that's changing with the blasted points. That's actually the basics of what I have done so far. You can change with the noises and different types to change the bottom as well, but that's it actually. So I hope you enjoyed it. I might go for the English tutorials as well after this one to actually catch up to my original Turkish ones. It will take a few months, but we can go there. After that, maybe there will be 2 tutorials in single week, one Turkish, one English, the same thing. But right now I will keep doing English tutorials to catch up to my current channel. If you want to see the effects, you can check them out as well. So goodbye everyone. Thank you for watching.